Hello, my name is Jasmine, and this is going to be a tutorial video on scientific notation. In this video, I'm going to define scientific notation and explain its purpose. I'm going to demonstrate converting from standard form to scientific notation, and then demonstrate converting from scientific notation back to standard form. So, let me pull up this. So, if you can see that, scientific notation is a useful way to simplify very large and small numbers. So in real life, the best example I can think of is scientists have to collect data all the time. They have to write down sometimes very large and very small quantities, and that can be very tedious to have to write a number that is like 10 decimal places long. It takes up a lot of time, and it can also get kind of messy. And also, if you were doing if you're doing calculations, it is incredibly hard to do calculations when you have to write down very, very long, tedious numbers, and you are probably more likely to make mistakes in comparison to if you were to use scientific notation during your calculations. So, some key things to remember is this is the format for scientific notation, and it's pretty easy to follow. A is a number less than 10, be equal to or greater than 1. And n, which is this number right here, variable right here, is a number, just a number, and it can be negative or positive. And it's also important to remember that negative exponents represent small numbers, which, and by that I mean numbers to the right side of the decimal. And positive exponents represent large numbers, which are numbers to the left side of the decimal, if that makes sense. And yeah, so now I'm going to show you how to use scientific notation. Let me just fix that here. Okay, so here I have 4 squares, and I'm going to zoom in a moment. But this side is, on this side I'm going to be converting from standard form to scientific notation, and on the top here, on this side I'm going to be converting from standard form to scientific notation, and then on this side I'm going to be converting I'm going to show you how to convert scientific notation back to standard form. And on the top here, these are large numbers. So these ones, if you can see, have positive exponents, and then at the bottom here, these 2 squares are dealing with very small numbers. Okay, so for our first 2 examples, these are 2 very large numbers in standard form. Now, the first step for converting anything to scientific notation is to first find the coefficient, of course, which is a, and to do that, you have to find, it can either be 2 or 3, but you have to find the significant numbers, basically. So for this one, it would be 6 and 5, so I would put the decimal there. And then for this one, it would be 7, 3, and 6, so I would put the decimal here, because 6.5 is in between 1 and 10, and 7.36 is also between 1 and 10. It can also be equal to 1, but you get the idea. So the second step is basically to move the original decimal place. So the original decimal place was right here. So we're going to ignore this for a second. And I moved it here. And I got here by moving 1, 2, 3, 4 places to the left. And I moved, I moved 4 places to the left. So this in scientific notation would be 6.5 times 10 to the 4th power, because I moved 4 decimal places to the left. Now for this one, the significant numbers are 7.36. So we're going to start with 7.36 here. And we got to this point. We first started here, right? And we got to this point by moving 1, 2, 3, 4, 5, 6, 7, 8. 8 places to the left. So this would be times 10 to the 8th power, because we moved 8 places left. And those are our two answers. Okay, so for our next example, it's basically the same kind of process, but we're going to be going to the right this time, which means we're going to have a negative a negative exponent. So here, we're starting here, but our significant numbers are 3 and 4. And we're going to be moving to the right this time. So we're going to start here and count to right here, which is 1, 2, 3, 4, 5. 5 decimal places to the right. So this is going to be 3.4 times 10, but because we're moving to the right this time, it's going to be negative, sorry, I had to sneeze. It's going to be negative 5, and that's our first answer. Now for this one, again, same process, find your significant numbers, which are 9, 8, and 2, so it's going to be 9.82 because it's in between 1 and 10, and we're going to move from here to here, so 1, 2, 3, and that was only 3, and because we're moving to the right, draw right this part, times 10, to the right 3 places, so it's going to be negative 3. And that's our second box. Alright, so now we're going to be converting scientific notation back into standard form. And because we're converting back to standard form, we're actually going to go kind of backwards for these exponents. So initially we went left for a positive exponent. Sorry, you can't see that. But this time we're actually going to go right. And so the best way I like to do this is I will write the significant numbers, which are 9, 6, and 4. And we started here. And I like to look at these two numbers right here. And already I can see this is 2 decimal places that we moved, if that makes sense. So I like to look at the coefficient here. And I like to subtract, if it was just 9.6, I would subtract 1 decimal place, or just 1 from 8. Which would be 7, but because there's 2, I'm going to subtract 2, which would make this 7. And then, I'm going to subtract 2, which would make this 6. And when I say make this 6, I mean that's the amount of zeros I'm going to draw. So, and that's just how I do it to kind of get like a visual representation in my head so that I know what to write and how many. So, we're going to start with 2 and draw 6 zeros. So 1, 2, 3, 4, these are kind of big zeros, sorry, 5, 6, and this is not necessary anymore, and the decimal place would be right here, but we don't need that, so this would be 964 million, and we can double check by starting here and counting to this place, so it'd be 1, 2, 3, 4, 5, 6, 7, 8, because we moved 8 decimal places, and we'll do the same process again for this number. So I'm going to draw the significant numbers, and the exponent is 6, but pretending there's a decimal place right here, there are two decimal places we already kind of have. So 6 minus 2 is 4, so we only need to draw 4 zeros. 1, 2, 3, 4. And we can double check by starting here again and counting 1, 2, 3, 4, 5, 6. So we know that we are correct. And this number is 2,670,000, whatever. Okay, now for our last one. Okay, so it's basically the same process, except we're going to be moving to the left side this time. So again, I'm going to draw my 2 significant numbers, and we're starting here. And I can see that I've already kind of moved 1 decimal spot to end up here. And I've already moved 1 decimal spot to end up here, which means I only need 2 more. So I'm going to draw 2 more zeros. 1, 2. And then I'm going to put the decimal right here. And we can double check by counting backwards. 1, 2, 3. And we moved this way, which means we are moving negative 3 places. And then for the very last example, it is 4 times 10 to the negative 10th power. And for this one, it's just 4 as our significant number. Actually, I'm going to move this 4 over here so we have a little more space. So the decimal for this, let me zoom in a little, number would be right here, and we're already kind of moving one space here, and this means we only need 9 zeros. So I'm going to write 1, 2, 3, 4, 5, 6, 7, 8, 9. It's kind of a lot. And then again, we can double check this by counting backwards. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that's where we started. Okay, so now that you know how to do scientific notation, you might be asking, well, when would I ever use that in real life? And there are a lot of different ways that people use scientific notation in their everyday lives, but one of a very common thing that people use the scientific notation kind of version of, instead of writing it in standard form, is the speed of light. If you take any physics or chemistry class, you probably have seen this number, which is 3 times 10 to the 8th power in meters per second. And the actual speed, this is rounded, the actual speed of light is 299, I think, million. I think it's 299.7 to something meters per second. But if you're doing calculations, or you're writing a paper or anything like that, you're not going to write out this whole big number over and over and over. And I'm sure if you're doing a calculation, like for example, if you're doing light energy or something like that, you're probably going to want to use this number versus this number, because this is so much easier to put in the calculator. You're way less like, this is so much easier to remember too, versus like, I cannot remember this part. This is so much easier to remember, it's cleaner, it's just overall better. And yeah, that's a kind of like a real world example of when it would probably be better to use scientific notation versus the original standard form of a number. So I hope you liked that video. My teacher is the only one that's going to see this, but if anyone else does on YouTube, leave a comment and a like. And yeah, thank you. Goodbye.